Hello everyone, I'm Nim and today we're going to be talking about the RSA encryption algorithm. So, what is the RSA encryption algorithm? Let's begin. The RSA crypto system is an encryption algorithm named after the three people who invented it. They're called Ron Rivest, Adi Shamir, and Leonard Oderman. Hopefully I pronounced their names correctly. So, the encryption algorithm is based on very large prime numbers, which means that decrypting the text is nearly impossible with our current technology, because there's no fast and easy way to factorize a number into its prime factors. A very large number. Okay, so RSA is an asymmetric encryption system. An asymmetric encryption system is a form of data encryption where the encryption key or the public key and the corresponding decryption key, also known as private key, are different. Each person will generate their own private and public key and send their public key to the person who wants to send them a message. Then they will use the private key to decrypt the message. Okay, the RSA crypto system works on the basic principle that e to the power of e d equals to m mod n. If you guys like this video, tell me in the comments and ask me to make another video actually proving this statement, and I'll do that. I'm not doing it in this video for the sake of simplicity, so we can keep it kind of short and get all the important points across. Okay, so the public key is represented by the integers n and e, and the private key is represented by the integer d. Okay, and m represents the message. Okay, now how do you generate the keys? First of all, you choose two large prime numbers, p and q. To make factorizing harder, p and q should be chosen at random, both to be large and have a large difference. Both p and q should be kept a secret. Next, you calculate n, where n is p times q. Then n is released as a part of the public key. Then you calculate the totient function of n, which I will explain in a second what it is. Then you choose an integer e that satisfies 1 smaller than e smaller than phi of n, or Euler's totient function of n. Which is represented by the Greek letter phi, and e must be coprime to phi of n. Then you choose an integer d such that d is the multiplicative inverse of e. This means that e times d mod phi of n is 1. I'll also explain that in the proof video if I make it. Okay, now what is Euler's totient function? Euler's totient function counts all the positive integers up to a given integer n that are relatively prime to n. Euler's totient function is mathematically defined as what you see right here. But luckily for us, we don't need to worry about that, because if n is a prime number, then the totient function of n is just n minus 1, because all the numbers up to it are going to be co-prime with it, which intuitively makes sense. So if n is a multiple of p and q, that just means it's going to be p minus 1 times q minus 1. Okay, so since d and e are multiplicative inverses of each other, we can use c equals m to the power of e mod n to encrypt it, and c to the power of d mod n to decrypt it. Okay, when you actually implement the algorithm, you would want to use you would want m to be the ASCII or Unicode representation of the message, so you could actually do arithmetic with it, because it needs to be a number. Okay, so now we are going to look on how we're gonna code it in Python, and I'll explain how to do just that. Okay, so we create a class called RSA, and we don't need to initialize anything, so let's just pass. And then what we want to do is generate two large prime numbers. So if you watched the last video I made, you would have learned about the sieve of Eratosthenes, which is a way of generating prime numbers. So I'm just gonna implement the code right here, and if you don't, I'm just gonna copy it. And if you don't understand it, I recommend that you watch the last video I made, and then you'll get a good understanding of what the algorithm actually is, and then you can come back to this video and watch it. And if you don't want to watch the previous video, you could just copy this piece of code. It basically just generates large prime numbers. It generates prime numbers up to n, and you're going to put them in a list. Okay, so the next thing you would want to do is generate your public key, right? So what you do is, let's call it gen public key self. Let's pass self. Okay, so first of all, we would want to call our sieve function. So let's create a prime list, and let's have self.sieve up to, let's do 1,000 just for the sake of this demonstration. But if you actually make it, and you actually intend of using it to send messages or anything, you'd want the prime number to be bigger than 1,000. But I'm just keeping it small for the sake of the demonstration. So then you'd want p to be a random prime number from this list, and then you would want q to be another prime number from this list. Oh, first of all, I need to actually import random, and now we can actually use that. Okay, so now we can say n is p times q, as we've seen in the PowerPoint, and then phi of n, or Euler's Tauschen function of n, is just p minus 1 times q minus 1. Okay, and let's create a list called e options, and then we can get all our values for the public key. So for I in range phi n, we would want to check if if our value for e is co-prime to phi of n, and for that we can use the Euclidean algorithm, which if you guys want me to, I'll make a video about it later. But for now, you'll just have to trust me on that. The Euclidean algorithm is a way of getting the greatest common divisor between two numbers. So it's going to be like this, and then I'm just going to write down the algorithm. So this algorithm returns the greatest common divisors between two numbers, and if it returns 1, so the greatest common divisor is 1, that means they're co-prime or relatively prime to each other. So now we've got that. That is the function we would use. So for I in range phi of n, you'd want to do if self dot greatest common divisor of I and phi n is 1, that means it's a valid option for e. So e options dot append I. And now you take e as random option from this list of options, and then you would return e, n, and phi n. Okay, now the next thing you would want to do is you would want to generate the private key, right? So define gen private key, and for that you'll take self, you will take e, and you will take n and phi n. It's very important that you keep phi n a secret. You can't send it with you, because that is the key to actually decrypting the message. So you don't want other people to have phi n, just yourself. Okay, so first of all, we create a list called d options, and you will see why in just a second. Now for d in range 3 to phi n, because 2 is prime, you don't want to take 2. So then you do if d times e is de mod phi n equals 1, which is what we've seen right here, then what you do is you add this to the d options, because it's a valid option for d, right? So you append that. Oh, that is a capital D. We do not want a capital D. Okay, so now d is going to be a random option, random choice from the d options. Okay, and now we're going to return d. So now we have a function to generate our private key, and we have a function to generate our public key. So now next we're going to create a function to actually encrypt the message. So define encrypt we're going to take self, we're going to take message, we're going to take E, and we're going to take N, because that's all you need to actually encrypt it. So, ciphertext, let's call it ciphertext, equals, now we're going to do some list comprehension method, and if you don't, and I might make a video on list comprehension methods in the future if you don't understand how to do this. So, what you do basically is, here you convert C. I'll show you, wait, I'll just make it simpler to understand. First of all, you do for C in message. So, you have a for loop that goes through the message, okay? And C is just each letter. And then what you do is, you do odd C, so you just convert C to a numeral representation. I don't know if it's ASCII, but that's just a Python function to do that. And then to the power of E. So we're just going to use the algorithm we've seen here to encrypt the message. We're just doing this, right? So now we're actually creating a list that each item in the list is the ASCII, I think it's ASCII, the ASCII representation of the letter, but encrypted because we're doing this. And not to forget, I need to do mod N, and now it's going to be encrypted. And now we're going to return ciphertext. Okay, now how do we decrypt the message? Decrypt. With oneself, ciphertext, N and D. Don't forget, D is a secret. You can't give your D to other people. D is a secret. Okay, so your message is going to be, this is another list comprehension method of taking a list and just joining it and making it a string, which is important for our point because we want it to be a string, not a list. So you would want to do for C in ciphertext. So you would want to take each item in the list in the ciphertext. You do character of C, and then character of C. Wait, I just need to remember how. Yeah, C to the D mod N. Yep, that should be it. So this will just create a message from the list. She's gonna take each item in the list, decrypt it, and then join it into one string. And then you would want to return your message. Okay, good. So now we have finished creating our class. So we would want to initialize our class and just do arg for algorithm is RSA. We're not taking any inputs, so that's good enough. Then let's do r equals arg dot. I'm just using a letter, it doesn't matter. It's just gen public key. This will generate the public key, and then you would want E and phi n. That's what you're unpacking from R. So it's going to be R0, R1, R2. This is just the same as doing E equals R0 and N equals R1. It's just a faster method. Okay, so now you want D to be alg dot gen private key E, N, and phi n. That's the inputs you need to take. Okay? And now you got all your keys, you got everything. So now you'd want to enter the message. Enter your message. Now, here you enter the message, and then you need to actually encrypt it. So your ciphertext will be algorithm.encrypt. And then you want to pass the message. You want to pass the public key, which is E and N. And then that would encrypt your message. And to decrypt it, you'd want to do message equals alg.decrypt your ciphertext that's been sent to you from the other person, ciphertext. Then you'd want to enter N and you'd want to enter D. So that will give you the message. And then you do just print the decrypted message is, now we're going to use an F string, message. Okay, now we're going to check if it works. So we're just going to run that. So open the terminal. Module random has no attribute choice. Okay, that's because I spelled choice wrong. Now we need to look for where that is. There we go. Now let's run it again. Enter your message. My message is, hello world. Python is too large to convert C. Okay. What have I done wrong here? Let's just debug it. C to the power of D mod n. Okay, I see what went wrong. This is not supposed to be in. I got my brackets wrong, so this should be fine. Okay, this should be fine. Okay, just wait a second. Oh, it already got outputted. Okay, that was quick. The decrypted message is hello world, so it works. Now let's give it another input just to test. This is a test message to see if the code works. There we go. This is a test message to see if the code works. And now, if you don't believe that the message is encrypted and you just want to see, we could put in ciphertext. And now, as you can see, this is just nonsense. You can't do anything with it, because that's a ciphertext. Unless you know the private key, and then you can decrypt it. So, that is it. That's how you implement RSA in Python. I hope you enjoyed it. And if you enjoyed it, please consider liking and subscribing. Thank you very much. Bye.